Okay, today this is the problem of the day about how we can use the separable method and also the homogeneous to solve a differential equation. So the question says we should solve the differential equation x squared plus y squared dx equals 2xy dy. So first of all, let's check if this equation is a homogeneous equation or it is a separable or exact or a linear equations, whatever. So in checking this, we know that the higher power or the higher degree of x is 2, and the higher degree of y2 is 2. The higher degree of x is 1. That of y2 is 1. So 1 plus 1, we are getting 2. So both the terms are of degree 2 or they are of power 2. There is another way to determine a homogeneous equation or a homogeneous differential equation. Homogeneous differential equation in such a way that the terms in the functions or the terms in the ordinary differential equations all are the same when the terms are of the same degree. So quickly, the idea is that we have to make a substitution to solve a differential equations related to homogeneity. So what we are trying to do is that for better and easiest way to solve, we have to reduce it to a standard form for easy substitution. That's what I always do my ODE. So trying to separate all the terms into a standard form, we try to multiply 2 by my dx. So we multiply the whole of the equation by dx. So multiply the whole of the equation by dx. So multiplying 2 by the dx, we are multiplying 2 by 1 over dx. So to get rid of the dx on this side, so the left hand side, the dx will cancel the dx, leaving x squared plus y squared, and the right hand side we are going to get 2xy dy dx. So into a standard form, we try to make dy dx stand alone. So we divide 2 by 2xy, then we divide the left hand side by 2xy. So getting dy dx equals x squared plus y squared all over 2xy. Okay, so we try to make this substitution for homogeneous equation. So my y is equal to vx. So we should always keep this in mind when we encounter a problem with homogeneous form like this equation. So by product rule, we can differentiate my y equals vx. So we hold the v constant, then we differentiate the x. So holding the v constant, we differentiate the x. Then when we differentiate the x, we know that because it's not a function in terms of x, we have to attach the dx to our differential equation. So this is just an idea by product rule to get this form. Okay, so by making the substitution on the previous slide, we saw that our dy dx is equal to v plus x dv dx. By using this equation or this formula and differentiating it by product, we obtain this. So wherever we see dy dx, we substitute v plus x dv into our original equation. That's the standard form. So quickly, my v plus x dv dx should be equal to x squared plus y squared over 2xy. So my v plus x plus dv dx equals to x squared plus, by we saw that my y equals vx. So wherever I see my y, I substitute vx. So giving us this. So my v plus x dv dx is equal to x squared plus, then because y is square, so we try to square the whole function vx. So we are getting v square x square all on vx. By remember, the x here is multiplying the x in the term, so we are getting x squared. So we try to factorize x squared from this equation, so x squared will come out. Then we try to also make the x squared come out. So my x squared coming out from the denominator, leaving 2v. So you can see that the down one x squared will cancel the numerator, the x squared, leaving 1 plus v squared at the numerator and 2v at the denominator. So the whole idea that we want to get rid of difficulties, so we are trying to make all the v get to the right side and all my x values get to my left hand side, or whichever way you prefer. So we try to send a v here, so when v comes here it becomes minus, but remember any number is over 1. So to avoid confusion, v is a number or it's a variable and it's over 1. So you can maintain my x dv dx here, then try to simplify this. So we find the LCM, then you know that 2v will go into 2v 1 times the whole of the numerator, getting this, and the 1 2 will go into 2v multiplying v, we are going to get minus 2v squared. Okay, so we try that we can multiply or cross multiply. All that we are doing is that we want to make all the x components get to one side and all the v components, the dv and the v component to another side. So we can try to cross multiply. Upon doing this, we achieve the whole this equation. So my 2v times x dv, getting this, my dx times it, we get 1 minus v squared dx. Okay, so my so after that we try to multiply 2 by 1 over x. So we multiply the whole equation by 1 over x. So x will cancel x, leaving 1 minus v squared all over x, and leaving 2v dv. So after that, we see there's still the x here and x here. So we can try to eliminate 1 minus v squared, or we to try to send 1 minus v squared to the left hand side. So upon doing that, we multiply 2 by 1 over 1 minus v squared. Then we multiply the right hand side 2 over 1 over 1 minus v squared. So my 1 minus v squared will cancel 1 minus v squared. Then the left hand side, we are going to get 2v over 1 minus v square. The equals now the right hand side, we are left with 1 over x dx. This implies my 2v over 1 minus v square equals the integral of 1 over x dx. So at this place, we try to integrate the left hand side and we try to integrate the right hand side. But we should remember, this is a function and a derivative. So this is the function. This is the function. My 1 minus v square is a function, and this is a derivative of this, because when we differentiate 1, we are getting 0. When we differentiate v square, we are getting minus 2v. So my minus will come. Then we know that when we integrate a function and a derivative, we are going to get ln of the function. So this is the function. So we are getting ln of the function. So the negative sign here represents this negative, because when we differentiate this, we are going to get minus 2v, but this numerator is positive 2v, so it will come out and affect my length. Then when we integrate 1 over x2, we are going to get ln x plus a constant c. So finally, the minus sign can be brought upward, then equal to my right hand side ln x plus c. So my ln 1 minus v square over my 1 minus v square or exponent minus 1 is equal to ln x plus ln c. Remember, this ln c is nothing. It's like it's a rule. Every constant, say c or k, can be written as a natural log of another constant. So because we are getting ln in these functions, we are about, or we want, or we decided to write all the c2 in terms of ln. So on doing that, we obtain ln c. So from properties of logarithm, natural log ln, when we are adding, we have to multiply, and that gave us this. So we know that my ln will cancel ln, then finally we are left with 1 over 1 minus v square equals xc. But then previously we made a substitute that y is equal to vx, hence making the v the subject from this place, we are getting y minus x. So making the substitution, wherever you see v from the solution, wherever we see v from this solution, we have to substitute y over x and giving us this. Thank you.